Okay, everybody. Well, thank you for coming to our session. This one in particular is about test cell automation, from low to no code to real-time test and data logging. So I'm really grateful for you all to be here. I know it's been a long and busy week, so it's exciting to go over one more topic, at least personally, and then wrap up NI Connect 2026. Let's go ahead and get started. Let me introduce myself. My name is Tyler Clifton. I'm one of our business managers here at National Instruments, specifically covering our industrial markets. I cover the Americas, but also help out a little bit in EMEA. And I want to talk to you today about electromechanical test cells. So maybe to get started, just so that we're all on the same page, what is an electromechanical validation test cell? Well, this in our mind, to just kind of set a stage, is a physical system, electromechanical system, going through some sort of test for safety or compliances or real world performance. So think performance testing, right? We're combining the device under test with support equipment that needs to be automated and gather data from that, as well as constantly evolving this based on the test requirements or new design specs that need to be confirmed, okay? So in this particular application, as we study it across the market, there's some specific things that we're noticing. There's this increased need for automation in the testing process. Obviously, automation is very popular, but it's more than just automating the test. It's also automating all of the support equipment included with the test to make the test possible, and getting all of that data back in a way that you can correlate everything that's happening in your system at any given time. Also, with the proliferation of AI-driven development and software-defined products, more and more products have embedded software on them. More and more of that embedded software is starting to be influenced by AI development. So now we need more human-driven test coverage in order to fully exercise this developed software for compliance, for coverage, to make sure that it's going to work as we expect in the field. And then this last one is a little bit more of a nuanced bit, this rise of edge-based testing for real-time insights. And what do I mean there is, now more than ever, we're getting lots and lots of data, but you can't just send every piece of data you have up to your cloud or data processing tool, because that can be really expensive. So applying edge-based testing means that we're able to do analytics down on the edge to determine what data gets saved, what data gets transmitted, and be more efficient with the data that we generate. All of these trends actually create an opportunity, which is they're creating a bottleneck with our test team talent, but that's the opportunity. Can we unlock that test team talent through no code or low code solutions that I'll show you more today? We purport that we can free up engineering bandwidth. We can allow our operators and our technicians to develop the tests according to test plans, freeing up that expensive resource to work on the most important or critical issues for the organization. Okay, so that's the opportunity. So how I want to do this is actually talk about a phased approach. Here are all three phases. The first phase being just get the data into the system. I need data from a test. The second one is, hey, I need more than just data. I actually need to control this with some determinism. And then the third phase of complexity in these systems for test cells is actually modeling or emulating subsystems of the device under test, because maybe you don't have the full system. Having the full system is very expensive in terms of an investment. So if you can do the test with less equipment to support it, then you can be more efficient. You can shift more of the testing to the left. Okay, let's start with the first one. Here we're showing you how we can make use of the NI platform, specifically using Compact DAC and our no-code software called NI FlexLogger. This software is measuring torque, RPM, vibration, temperature, voltage, and applying variable load to our drill that's under test. So in this case, if you've had a chance to go down to the expo floor, there's a power tool demo there. This is actually that demo. All that's being done is operators issuing the start to the test with the drill button, and FlexLogger is doing the rest. Also, just as an optional fun fact, a lot of this data is also tied to system link, so that if you had multiple of these drills, think of them multiple test cells, you now have data observability across your lab. So this is an example. Now, since I couldn't bring that heavy demo in here, I'm going to show you the demo on this next slide.
All right, Jeff, let's just jump right into it. Let's test the torque on this power drill.
Let's do it. Here we go. We're going to spin this thing up, and then we're going to apply some torque through this linkage with the brake.
Let's do it.
So we're going to spin this thing up, and then we're going to start applying brake. And there we go.
So I heard the clutch kick in. So it sounds a lot like the drill that I have at home when it bears down and then the clutch kicks in. And so this is a great example of a test system that a manufacturer of a power drill could use to characterize their torque profile across all.
Okay, so what that was really showing is that zero code was used to operate this test, which is really powerful. Again, if you can imagine a test plan being available, an operator can just come and apply the test plan to the actual test fixture, no software needed, and the engineer can focus on the data that was generated from the test. What FlexLogger is providing is a test system UI, again made with no code. And then channel configuration, configuring your DAC, configuring your data rate, the types of channels that you have, the signal conditioning, the sample speeds, the logging location, everything about this test is completely configured in a user interface, again, with no code. So developing the test with no code, we see how that works. But what about modifying it?
Instantaneous G's right off of that sensor. What if we wanted to swap that out with like an RMS calculation?
Yeah,
so we'll walk through that.
Let's add that. So we mentioned no code. One of the values here is I can do some of these more fundamental calculations with simple configuration.
Yes.
So I'm going to add an RMS channel, and I'm going to map it to my instantaneous acceleration, right? So I've got, let's go down here to my 9234.
So all your channels are in that tree.
Right. I can see all the physical channels as well as my local variables and my local calculations, and I can reference those in other calculations. So in this case, I'm going to select my motor vibration, and now I can configure how long I want the block size, and now I can see RMS acceleration there. So now if I want to add that to my front panel, I can just simply go in here, right click, and let's map that to an indicator, a numeric indicator. Let's look at that here. So you can see I just did RMS. I can type that in the search, add that here, and now I've got RMS acceleration.
So again, to show this, we modified the test, adding another metric to measure and to data log, in this case, the RMS, with zero code. So just through some configuration, that's the kind of power you can expect out of FlexLogger. So maybe to summarize FlexLogger a little bit more specifically, you can get from nothing to logging data in very short amount of time, in minutes, right? You can also build the ability to do some cycle-based testing in FlexLogger through, for performance type tests like I've shown you, going over different torque settings. And then you can, of course, scale this and share the FlexLogger projects across your different test setups. That's the first step of electromechanical validation test cells in terms of just getting the data. And to give you a customer story on this one of our customers specifically makes health fitness equipment. Historically, they have used a partner of National Instruments to do all of their development because they couldn't justify the development costs. And the partner actually develops several types of systems, but for their long duration tests, occasionally they would need to make changes that just took a long time to implement, to prioritize. But through the advent of FlexLogger, they were able to bring that back in-house, make those tests themselves, generate the data sets that they require, all increasing the speed and not requiring a LabVIEW skill set or licenses that they would be required to do that development. So that's how they made use of the FlexLogger technology to do those long duration tests. Okay, but what happens when you go from just a data logging application with some basic sequencing to needing to real time? So I need to do things very deterministically. I need to do them in an order. That complexity doesn't exist in FlexLogger. What do we do about that? Well, the good news is when you use FlexLogger, you get to use the exact same I/O that you used in FlexLogger, that you would use in a deterministic application. So you're not buying a separate test system. You're not getting a different test asset. You're actually using the exact same test asset. And in this case, I'm showing a compact Rio running Linux RT. It's our rugged, fully integrated platform that uses, like I mentioned, the exact same I/O as we used with the drill performance test solution. And all we're doing here is suggesting using the same hardware with a different software. So in order to talk about that, I'd like to invite Luca up here really quick. And Luca, I'll have you introduce yourself in a second, but I'm really curious if you've worked with customers, because you've been partnering with NI for a long time, that have had this data logging application, but then found themselves needing some extra complexity like deterministic control? And how have you and Synovis helped make that possible for them?
Absolutely. Oh, sorry. Thanks, Tyler. Yeah, we've had a lot of customers who have had, CDAC based or other kinds of platforms, and they're looking to add maybe more reliability or more determinism. So this has definitely been something that we've worked with in the past. So I'd like to talk a little bit more about SymplifyNow, which is our platform that kind of allows for this easy no-code integration and adds that determinism. So what is it? It's a compiled, ready-to-run application that's compatible with the 9040X series compact RIOs. It gives you a very quick setup from an off-the-shelf unit to being able to collect and run tests. It's fully headless, so everything's running entirely on the compact RIO once it's set up. There's no need for any external computers for any configuration, and it's very customizable. So the source code is available, and there's lots of options for kind of scaling and extending the application. Oh, that was the wrong button. So now, where does this fit into the kind of test ecosystem? So there's a few NI offerings that I'm sure a lot of you are familiar with in TestStand, VeriStand, and FlexLogger. And each of those softwares kinds of fills a niche and does a really good job at what it does. But there's certain cases where what you're trying to do doesn't quite fit into the circles that those applications work for. And so SymplifyNow kind of fills that role when that's kind of what you're looking for. So it's got some features that some of these other applications have, like it has, the logging capabilities that FlexLogger offers. It has the sequencing capabilities that TestStand offers, and it has real-time control capabilities that VeriStand offers. But it's wrapping this all up into one easy-to-use package. The other thing I want to mention is that this application is very data-centric. So it's very focused on collecting and being able to analyze a lot of data and high-quality data. And it also is able to kind of aggregate data from not just your DAC, but maybe other instrumentation like a power supply or a load bank into one central software. And by being able to put all of that information onto one display allows you to make maybe better engineering insights or better observations, and kind of giving you that one platform to bring all of your data into one place. So where and what applications would you use this for? So, the big ones are headless data logging and control applications. Ongoing monitoring and field trials, these kinds of applications where you need reliability and long-term endurance, where things are just going to work for you. This is kind of where you want to employ it. And, with the no-code configuration and headless operation, that's kind of enables you to do that. And then on top of that, you've got real-time sequencing and profiles, and being able to, log on triggers or perform operations on triggers. These are all kind of out-of-the-box features that help enable you to work on those applications. And then, as I was mentioning, this is a very extendable platform through LabVIEW and also Python. And I'll talk a little bit more about that shortly. Going back to sort of the data side of things, being very heavily focused on data, we kind of have two streams of data, or two different mechanisms for the data management. So we've got what we call the high speed and the low speed data. So the high speed data is kind of your raw data acquisition rate in here. That's like the 51 kilosamples a second data that's used for, your TDMS logging, your kind of analysis. So if you want to do like an FFT or something like that and perform that detailed high data bandwidth information. And then we've got kind of the low speed data that's used for kind of that live analysis, edge-based decision-making, closed-loop control, and that's at the kind of the 20 hertz range. So those are kind of how we're breaking down the data in the system. And now talking about the customizability, there's kind of 4 different mechanisms or 4 different steps of customizability that's available in this solution. So, your first one is your out-of-the-box experience. And that's kind of enabling, to set up your DAC, set up some triggers, maybe set up some simple sequences and profiles for basic control. And these are all sort of the out-of-the-box, no code, no additional steps to get these things up and running. Beyond that, if you want to add some additional extensibility, we have Python support on the compact RIO that's really easy to set up. And that gives you, the option to add things like, system link integration, emails on triggers, pushing data to like a database or maybe an IoT server, things like that, without, again, having to really write a substantial amount of code or become familiar with LabVIEW RT. Beyond that, you can then deploy LabVIEW code directly on the Compact Rio, kind of in a plug-in style architecture. And that allows you to maybe focus on very small portions of LabVIEW without having to really look at writing an entire application. And that can maybe work if you have a specific VI that you want to deploy, but you don't want to deal with all the other moving parts. And then option 4 is basically taking that source code and building your application on top of that with a fully custom UI, a fully custom driver suite. And so having access to the source code gives you the ability to do all these things. And we were lucky enough today to have one of our customers who went down that route to talk to us a little bit more about their kind of experience and journey. So I'll invite Akshay to come up here to talk a little bit more about that.
Thank you, Luca. So I am, okay. Hi, I'm Akshay, and I am a researcher with Purdue University. And we had this system that was built by NRC at Purdue University back in the 1990s. It's very old now, 35 years old. So this system was built by the researchers of the lab, and it has about 500 instruments, so 500 signals coming in, and about 120 controls, so signals going out. And this facility is capable of simulating boiling water reactors and generating licensing confirmatory data for the NRC. Now, because the system was built in 1990s, all of the technology is based in 1980s. And that system cannot be serviced efficiently anymore. So we need to modernize it. Alongside the restoration of the original facility capabilities, we wanted to add new stuff for the new age that we are going in, such as digital twin, data redundancy, data transfer capabilities, cybersecurity, stuff like that. Then, moreover, a facility of this size, with so many instruments and taking care of the whole facility itself, we would want a solution that is so intuitive that we can train somebody to work on the facility within, let's say, 6 months. So we went towards one of the routes to do that, and that's what SymplifyNow gives us. So let me introduce you to Puma a little bit, just the control side. So that image that you see, that's our legacy control system. And to be honest, you had to stand in front of it, monitor everything, and if something went wrong, you had to go in and turn the knobs on and off on your own. And we, at the end, we did not have a lot of documentation as well. So this is one of the simplified piping and instrumentation diagram that we have. Most of our stuff that we developed is based on the piping and instrumentation diagram. Most of the things were lost in 30 years of facility just being standing there. Also, the older data acquisition system was based on the DOS C++ program, and it would only display about 4 to 5 parameters. And we could not see everything that is going on with the facility. So that's why we have all of these knobs and things that are going on. And then our control system was basically this. This is our control system. So now what we have built using CDAC and CRIO is we have all of the temperature measurements being taken on this side, all of our current measurements being taken on this side, and this is our control side. So you can see we have CDAC, and that's our CRIO. All of this is connected to Ethernet lines using 2 switches, so it also provides us with data redundancy. And then those are the UIs that we made for the control. So that the top one is interacting with CDO, and you can touch it at multiple points. So that touchscreen, at least the touchscreen is capable of 10 touches simultaneously. I don't know if the software is capable of doing that. We'll figure that out. And so that guy is replacing our older system, which is this guy. And then we have an operator-based view. So that can be the test supervisor. So test supervisor can just stand in front of that screen and monitor what's going on. And if he wants to intervene, he can intervene. Then we have test operators. So we can have people who would just sit on the system and monitor the whole thing, what is going on, how it is happening. Is there some discrepancy that we are not able to see? And they can monitor it. And also we have exploded views of all of these vessels. So that's also pretty neat. And the biggest value that we get out of using SymplifyNow is the revitalization of Puma facility is a huge project. And data acquisition and control is one part of it. And using and leveraging SymplifyNow allowed me to create the whole control room software without even pulling one wire in LabVIEW, right? That's pretty incredible. 500 instruments, 120 controls, and I did not pull a single wire. That was amazing. Back in the day, there were 20 scientists and technicians who would maintain and work on the Puma facility. Now we are a team of 5 and we can do the same thing. I cannot say more about troubleshooting. Like Monday, when I had to travel the next day, we were doing some tests and we got stuck at some place. I called Luca and he's like, oh, I can do it on my phone. And then he set it up in like 5 minutes and we were able to do our test. And I was able to travel with a very free mind. So that's much more than you can hope for, right? At least for a system that big. And as I told you, like it's a system which is that huge, it is very hard to train people on it. And as a university researcher, we have always an influx and outflux of people. We have students coming in, they will join us for 4 years, and then they will leave. You need to make sure that they can learn the whole facility within a time frame, and then they can add something on top of it to do their own experiments, do their thesis, their research. And then by the time they are about to go out, they should be able to train their replacement as well. So all of this within a span of 4 or 5 years would not have been possible if the system was not intuitive. Now that the system is very intuitive, you can see everything like a PNID diagram. It makes our life much easier. Now that one, this I would like to emphasize a lot. So pathway to own and upgrade. As researchers, we always want to leverage the things that we already have, add on top of it to create something that does not exist yet. And that is one of the biggest things that we look for. If we would have gone any other route, we would have just gone a turnkey system that would have broken down the moment we tried to upgrade it. SymplifyNow and Synovus allows us, and basically they allow us to own the software, and they would train us to maintain and upgrade the software. So it's a pretty amazing tool, and that's all I have. So Luca, you can.
Thanks, Akshay. I'm sure. I'll give this back to Tyler. He's got some more interesting stuff to share with you guys.
Thanks. I think that's a very powerful testimony to the Synovus solution, and hopefully you guys are getting a sense of just the scale that it is capable of doing. And this is the exact same I/O that we were using a second ago to test health fitness equipment, right? And all we did was change the software. It's a very powerful tool that Synovus has created. So thank you, Akshay, for coming and sharing. Again, what an amazing testimony. So very good. Okay, so step 3. or phase 3. We've gone from I need data, I need it right away, to I need to control and run sequences. I need to maintain positive control and authority over my facility to exercise experiments. Now, I need a little bit more nuance, which is I need to be able to do this test with some emulation. Why? Maybe I need to perform a test with only part of the whole product, so I have to emulate the other pieces. Now we're talking about using models, integrating models, and doing that in real time. And that's something we make another software for called VeriStand. So hopefully you're beginning to see this story here, which is, again, without changing any hardware, we're beginning to add this capability. So as your test requirements change, you're not making this investment again. You're just using the exact same platform built to be extended through software, and in this case, VeriStand. VeriStand is one of our core application softwares. It's a unified test controller. It's our ready-to-run hardware-in-the-loop software. It's built for low to no-code applications. It's built to quickly configure the I/O, the channels, the alarming, data logging, the stimulus profiles, real-time sequences, as well as integrate those models that you need to run in real time to emulate the components of the system that are not in your actual device under test. It also has customizability. And if you do need to automate VeriStand, which is running different types of real-time emulated tests, we can do that through Python. So Python automates VeriStand, or TestStand. TestStand can automate VeriStand. Let's talk about what model integration looks like. So VeriStand takes in models that follow the FMI 2.0 or 3.0 standard. Basically, a model that exports as an FMU, right? So any software that makes an FMU, by the way, if you don't have software that makes an FMU, LabVIEW can make an FMU. And if you need a model to be emulating components of your system, it's a matter of deciding what kind of response rate do you need from that model to emulate the missing components in your system level test. If you need nanosecond level response rate, we have the FPGA in our integrated controller in the Compact Rio. If you need something at the microsecond level response rate or even slower, the real-time CPU is perfect for this. All the while keeping it fully synchronized and managing the I/O in our system, the C-Series I/O. That's interfacing our test cell or device under test. And I kind of already mentioned some of this, but you can use LabVIEW to create FMUs through LabVIEW, a LabVIEW project. And then you can also use MathWorks Simulink software to create models there. But really, any modeling software that creates FMUs, you can use. And it's as simple as selecting the software tab in VeriStand, selecting simulation model, and then pointing to the FMU. Okay, so to kind of give you an example of what this test looks like, to maybe gauge, can you imagine yourself needing to do some emulation? I'll show you an actuator test. In this case, I'm doing some performance testing. I want to apply a max spec condition. Maybe this is an actuator for an airplane wing or something along those lines. And I need the load that I'm applying to the actuator to be according to a profile, and it has to happen in real time to mimic a takeoff scenario, right? Additionally, if you're doing environmental tests, it's the exact same equipment, exact same software, but maybe you're including a chamber or a lifecycle test, which you're just doing this test constantly. And all the while, again, the same test setup works. This particular demo is not an NI Connect, and it is even larger. So again, I have a small video just to show it.
Huge up on how it's that. So what is VeriStand doing for us? Yeah, so what VeriStand lets us do is it allows us to take that model that is looking at the dynamic load and saying, what should the load be at any point in time? It allows us to run that in a real-time environment and then very easily connect all the model inputs and outputs to physical I/O. All right, and so the model then is developed so our model was developed in LabVIEW, but we often see models being imported from Simulink or just any C or C++ environment, or really any modeling environment that lets you export an FMU. So that's like the power of VeriStand is that it allows you to bring all those different models and controller to put them all into one environment, coordinate among those different pieces, and run those together. TestStand then is doing the sequencing to say, we're going to run this part of the test now, this part of the test, and generate the reports to come from that. Yeah, our pass-fail report, pushing out through database, exactly. Excellent.
So again, hopefully you're beginning to see the power of our hardware and our platform. And when you make a companion software with it, you get even more capability. So starting again from data logging, going on to real time, and then adding emulation, all on the exact same hardware. To give you a customer success story on this one of our customers was developing a hydraulic steering valve. Actually, they developed many hydraulic steering valves, but they also have to do a lot of root cause analysis. When things go wrong in the field, they bring it back. It's the exact same test cell that does this testing, this performance testing and root cause analysis. The challenge is that their testing velocity was increasing, and they needed to be able to automate this in order to pick up speed, to not have a deep backlog. So they had to increase focus on this so they could also get data for their own product designs, make adjustments to the designs, but also get feedback back to these customers that had issues in the field. So with a lack of bandwidth and a lack of speed and test, they looked to VeriStand and implement a test that was done with emulation through VeriStand through modeling and model integration, where the technicians could implement the test themselves in VeriStand, because VeriStand has the ability to implement sequencing and go through a test plan and test profile. So the engineer produced the test plan, the test operator or the technician in this case actually did the implementation in VeriStand themselves. No code, just configuration of the profile. And that allowed the engineering team to focus on the data analysis. So they would issue a request for tests, the operator would perform the tests, configure the tests, perform the tests, and then supply the data packaged according to the test plan for the engineer to review and communicate and also iterate on the design. So again, a huge power just by changing software. So hopefully you've heard the arc here, getting started with data and data logging, adding the increased complexity through determinism, as well as emulation for control validation. And just to kind of summarize a little bit, why is it even important to mention this? We make a really amazing software, but our partners make amazing software that continue to find answers to the gaps in the overall test solutions that are needed out there. When you're looking to make an investment and you don't know what kind of testing you're going to do, but you know at one point or another you might be in phase 1, 2, or 3, maybe get on a platform that allows you to grow. That's the idea here. Start testing in minutes, you're getting results right away. You can scale on the same hardware, and you can extend with almost no limits. But if you need help with a business justification, consider the amount of engineering return on investment, because you're not buying replicate test assets to do the exact same function, you're just changing software. And then you get to right size the test investment and appropriate skill level to execute these tests, and then free up resources. This is actually my last slide. I'd be curious if there are questions for our customer Akshay, our partner Synovis, or myself.
One question for Akshay. Do you have a chance or the need to extend the functionality of SymplifyNow using Python?
Oh, really fast. I'll repeat the question. So the question was to our customer, if you want to come up, Akshay, have you ever had the need to extend the functionality, and was it through Python?
Yes.
Through Python.
Yeah. A funny story. 1 month ago, I realized that the legacy hardware did not work directly with the system. So we had to introduce something in between that can bridge the gap between the two. To work that guy in the middle, we used Python. And Luca just gave me a script like, this is what's going to work, and it's pretty readable. And he did not even tell me what to do. I changed the stuff, and it worked. It's very easy. Yeah, it was super convenient. Thank you. Any other questions?
Yeah, any other questions? Okay, thank you very much, and I hope you enjoy the rest of the conference.